Hello everyone, and welcome to this presentation on speed as part of PIARC's Global Road Safety Knowledge Exchange. My name is John BARRELL, and I am an international road safety consultant who's worked in many low and middle income countries over the past 40 years, usually as part of internationally funded road improvement and safety projects. I'm also a member of PIARC Technical Committee 3.1 Road Safety. Today I want to talk about speed and its impact on road safety and in particular road casualties. During this presentation I will cover the fundamentals of speed, its issues, appropriate road safety interventions to control speed and recommendations for their implementation. So let's start with the fundamentals. The severity of injury and survivability of a road traffic collision is strongly related to the speed of impact. The faster the vehicle speed, the greater the impact and the less likely the survival of the casualty. For every 15% increase in mean speed of vehicles, there's an 88% increase in risk of fatal injury. Conversely, reducing speed by 15% will lead to a 52% reduction in fatal injuries. These effects are even greater for unprotected or vulnerable road users such as pedestrians, cyclists, and even motorcyclists. The critical component in any injury collision is the vulnerability of the human body. Pedestrians and cyclists have no protection in the event of a collision and with a motor vehicle, and their risk of survival reduces substantially above an impact speed of between 20 and 30 kilometers an hour. For occupants of motor vehicles involved in a side impact collision, such as at crossroads, the risk of fatal injury starts to increase at about 40 kilometers an hour and rises substantially from 60 kilometers an hour. On an undivided single carriageway where head-on collisions are likely, fatality risk increases for vehicle occupants of between 60 and 80 kilometers an hour. The issue with speed is that the more complex the road environment, the more information drivers have to process and the longer it takes to react to potential danger. Therefore, roads that are less complex are generally designed to operate at higher speeds. They're straighter, they have less junctions or intersections, they have separate traffic speed streams by direction, and provide segregated routes for vulnerable road users. The collision and injury risk increases when users adopt a speed that is not safe for all users. And this relies on drivers understanding the elements that influence speed. In rural areas, the presence of a physical median, preferably with a median barrier to separate oncoming vehicles, a wide-paved shoulder free of obstruction that allows vehicles to recover safely in the event of loss of control, will lead to high speeds. The frequency, formation and complexity of intersections will act to reduce vehicle speeds if drivers are given sufficient warning and visibility of their presence. A frequent occurrence in low and middle income countries in rural areas is the use of shoulders as pedestrian and cycle routes close to moving traffic. These are extremely dangerous, and separate provision for pedestrians and cyclists needs to be made away from these traffic lanes if higher speeds are evident. Additionally, rural routes will pass through or next to small settlements, where uncontrolled access for vulnerable road users and their animals will occur. Keeping these separated from the higher speed traffic is difficult, and lower speeds will need to be achieved if these roads are to operate safely. Within population centres, vulnerable road users close to the vehicle running lanes will be inevitable, and provision of shoulder space will often be used for parking or maintenance of vehicles, even street vending. Intersections will be closer together, less regulated and variable in their type and volume. Congestion at urban intersections is typical, and this will result in a lot of vehicle stopping, pedestrian crossing and late lane changing at short notice. Consequently, without clear regulation and segregation, lower operating speeds will be more likely in populated areas, Fundamentally, it is the behaviour of motorists on the road network that leads to misjudgments and the resultant injury collision. Everyone is different and reacts differently to the road environment, but everyone believes they're better than most in driving, and speed limits and regulations don't really apply to them. They are nevertheless influenced by what goes on around them, how others behave, what sort of day they've had, how tired they are, and what distractions are present. All these factors slow reaction times and make it difficult to cope with increasingly complex road situations. No two road users will react in the same way to the same situation. So what can we do to make life as simple as possible and provide appropriate safety measures? The UN Decade of Action identified a simple process for working out what needs to be done, how and by whom. And it is only by taking a holistic and cooperative approach between all those involved that road casualties can be totally eliminated and a wholly safe system created. The safe system advocates that a system that knowingly creates harm to human beings is unacceptable. But human beings make mistakes and are easily damaged. It recognises that safe roads and their use are everyone's responsibility, and that interventions can be made before crashes happen rather than only dealing with where they have happened. Being proactive rather than reactive. Road crashes are rare random events and may not happen at a particular location for some time. It is therefore better to identify those factors that lead to collisions and allow people sufficient opportunity to recover from mistakes without serious injury. To achieve this requires a degree of redundancy in the system to allow all these variations of behaviour to happen. To work towards this, the second decade of action has set a goal of reducing road traffic death and serious injury globally by at least 50% between 2021 and 2030. Managing speed is critical to this safe system approach, and remembering the earlier statements of risk of injury to vulnerable road users, where these are present in an urban area, actual speeds, not just speed limits, need to be restricted to 30 kilometres an hour. Speed management techniques are developed to ensure that the operating speed of vehicles is the same as the safe speed under all conditions. Even when the posted speed limit is set, it does not mean that the driving to the speed limit is safe under all conditions, and users need to be aware of the effect that weather and traffic volumes have on the safety of travelling to the posted speed. Three key components to operating speed are that it should be safe, credible, and in line with the posted speed limit. If the operating speed exceeds the safe speed, then the risk of injury to road users increases dramatically. The best way of ensuring that the operating speed is the same as the safe speed is to make the road self-explaining. This means that it's obvious to the user what is the safe speed by the physical layout and the road environment. Wide, straight, open roads lead to higher operating speeds than narrow, twisty roads with a lot of junctions. Therefore, the speed limits applied to these roads need to reflect those characteristics to be credible. For speed limits to be credible, signing needs to be in the right place, reflecting the road characteristics consistently, and be applied over the whole network. Visible in light and weather conditions, well maintained and consistent with other road markings and delineations. If the physical environment does not make the posted speed limit credible, then additional measures are needed to reduce those inappropriate operating speeds. There are a range of speed management interventions that can be used to reduce operating speed that deal with the three main components of crashes: the road, the vehicle, and the user. With the road, inappropriate speed can be controlled by physical features that lead to natural observance of safe speed limits. These can be vertical deflections such as road humps or cushions, or where pedestrians are likely, a raised road crossing. They can also be horizontal deflections such as chicanes or roundabouts where approach speed can be controlled. One difficulty with any horizontal deflection is that it has to accommodate both large vehicles and small powered two-wheel vehicles, which are inevitably more manoeuvrable. Improving vehicle technology and legislation is making it possible to moderate excessive driver behaviour by automatically limiting vehicle speed and adapting to change in posted speed limits either through GPS data or by reading roadside information. When all else fails, behaviour is modified through legislation and enforcement, with financial and ultimately licence removal for those repeatedly caught exceeding speed limits. The aim of these measures is to reduce the operating speed of vehicles to maintain safe speeds in all conditions, and getting the balance between deterrence and acceptance of the correct speed is vital. Where isolated change is needed that cannot easily be seen in a general road environment, additional warning through deceleration markings or rumble strips approaching stranging in conditions such as bends or settlements is used. Additional enforcement can be brought in at speed problem locations by setting up speed cameras to monitor driver performance. There are usually special criteria built into local legislation to ensure that these enforcement measures are objectively applied and not just seen as a way of raising local revenues. Enforcement should be the last resort to speeding. It's much better if the general public respond to the other measures to changing speed behaviour, making all speed limits credible to where they are placed. To improve driver compliance with speed limit, the signing needs to be improved where it is not credible. Driver education is needed as to why speed limits are necessary and the penalty for ignoring them, followed by stronger targeted enforcement. Better still, change the road environment to make the speed limits credible so that the road characteristics match driver expectations. So what are the basic recommendations? Speed management is not only about regulating speed, but also planning and designing appropriate road layouts to ensure safe travel speeds for all users across the whole network. Where different and vulnerable road users interact with motorised traffic, then speeds need to be lower than on wide, segregated open stretches of road. To reduce operating speeds to a safe level, then improving the readability of signs and the modification of the road environment either physically or through enforcement to make drivers aware of the changes in character and use. Where higher speeds are appropriate, then the road environment needs to reflect this in wide straight roads with segregation of movement and modification of the environment. Managing speed through behavioural change or speed compliance is necessary where the road is not self-explaining and requires education or enforcement through a demerit or penalty system. Engineering treatments are appropriate at identified high-risk locations where speed is an issue, but can only be applied more widely where particular features are known to be the cause of speed-related injury. In these instances, traffic calming or junction redesign can be an option. Increasingly, technology is providing additional means of managing excessive or inappropriate speeds, taking the choice of speed selection out of the hands of the individual. Managing speed effectively is a key priority in applying the safe system approach, and PIARC continues to provide up-to-date information and promotion of road safety worldwide. This new knowledge-sharing campaign will be regularly updated, covering all essential road safety areas. And further sources of information are available through PIARC that are listed at the end of this accompanying presentation. Thank you for your attention, and if you would like any further information, please contact me via the links provided. Stay tuned. for more action and events. Thank you.